This conference will now be recorded.
So you're able to see my screen, right? Am I audible?
Yes, we can see your screen.
All right, thanks. So we spoke about the non-functional requirement gathering. Okay, the different case studies, like what a performance has engineer has to do when he has to do with what is his roles and responsibilities right from the non-functional requirement gathering till the sign off. So yesterday we spoke about all the different the various roles that a performance engineer will involve in each and every individual phase of performance testing life cycle, and also we spoke about a little bit of performance engineering life cycle. Today, however, I'll explain you about the performance engineering process. And this can be very new for all of you, because most of the areas in performance engineering process, right? It is not only the single performance engineer who will involve. It is it is a list of people, right from the architects, subject matter experts, business analysts. Everyone will involve to define the plan for the performance testing full life cycle implementation. Okay. So yesterday I also spoke about the production traffic analysis, how to analyze this production traffic. Okay, how to design a workload model. I'll share an article on that, how to create an efficient workload model. And we also spoke about roles and responsibilities. The career into performance engineering, we already covered this in the first class, in our first demo, about skills that are required to be a perfect performance engineer. And today I'll talk about performance engineering process. Okay. So I have written all these articles about performance engineering process. So the most important parts in performance concepts in performance engineering process are how do you do architecture design, how do you create uh, hardware sizing, how do you do code optimization. I'll show you my 3 articles. You can directly go through from here. Okay. This is the first one I spoke about, tuning and transforming a career into complete performance engineering, from performance testing to performance engineering. And yeah, you can also check this article, which is fundamentals of performance engineering. This also talks about uh, the performance engineering process. Okay, so this will clearly explain you what exactly a performance engineer has to do in with respect to performance engineering life cycle. And there is a process actually, what phases, what you have to do in each and every individual phase of performance engineering life cycle. Okay, before you start doing performance testing, you need to understand few areas. Okay, there are some metrics you need to understand, the baselining and benchmarking of that. You need to look at few basic metrics. Okay, so that metrics are like I have clearly mentioned here. The first thing is the end user metrics. In the end user metrics, you should know the response time for a one user. Okay, which is a part of baselining and benchmarking. If you are recording one script with one user, you are calculating the response time for that particular use case with one user. That is how you baseline. And when you benchmark, you do some couple of tests. You run some pilot runs for a couple of minutes, for 10 minutes or 15 minutes or 30 minutes, to see whether the response times and utilizations are consistent. That is how you baseline and benchmark. And these are few metrics you need to understand from the architecture side, and from also from the infrastructure side, and from every individual tier. This is called tier to tier response times. There are some breaking timing targets. Let me give you one example here. So if a customer is asking you to achieve a response time of 3.5 seconds for a such transaction, okay, Such transaction is nothing but you type in some random unique employee ID or some credit card number in the search bar and you click on search. So the actual process from the back end, what it does is it goes from the client, it goes to the firewall, then it goes to the load balancer. From there it goes to the web server. Then from web server to app server and app server to DB server. In the DB server, there is one query that will be executed with some conditions and it has to fetch some appropriate data for the user that he is requesting, depending upon what input he gives. So when your customer is asking for 3.5 seconds, you need to understand some base targets by talking to some teams, engineering teams, development teams, because for such, initially there will be a one coding snippet from the development side to compile it, to run it, to execute it, to get the output from the coding from the unit level. It will take a minimum of 0.9 seconds. Okay, you understood the point? So for search activity, from the coding point of view, when he is compiling it, when he's debugging it, when there is some response from that code snippet, it will take a minimum of 0.9 seconds. Okay. For the query to get executed on the respective table in the database, it will take 0.6 seconds, which is now taking 1.5 seconds at the very initial stage. Okay, the base time that it has taken for executing that code snippet to get the desired output, then to get the query executed from the respective database, from the respective table where our application is accessing, it is taking a minimum of 1.3 to 1.5 seconds. If you don't know these base numbers, which happens from the development side or from the database side or from the execution side, you say to the customer that we can achieve response time 3 seconds of response time with when we test with 1,000 users. When you do that, it will become a false promise and a blind commitment to the customer, which will put you into escalation. So that is why the reason you have to be a part of performance engineering process to understand the round trip time, the response time, which is round trip time in the infrastructure. Then in that round trip time, you need to understand how much time it has taken for traveling from web to app, app to DB, and DB to client. There are some timing targets. I'll show you that. So before you take part in performance engineering process, you have to know the response times. You have to understand the access time, the completion time, and the interaction time. There is something called performance testing dictionary in Google. You can search there and you can get all the differences of what is response time, access time, completion time, and interaction time. Okay. From the application side, you need to understand what are all the different components that are part of our infrastructure. And just now I told you tier to tier response times. If the total response time in the infrastructure is 3 seconds, you will break that 3 seconds response times 3 seconds response time into bits and pieces. So how long is it taking from client to firewall, then firewall to load balancer, load balance to web server? The most important part is how much time it is taking from web server to app server to database server. Okay, from database server you directly get the response to the client machine. So you need
Krishnan,
to
here,
yes.
I have a question here.
Yes, please.
How do we break up this tier response time? Like, how can we extrapolate this? Like, get this details?
Right, I'll show you that because see, when something is unit tested, right, especially from the microservices architectures, every code snippet is unit tested before it gets integrated to other component. Okay, when they are integrating all of them into one centralized console, where we call it as a build, when we test it on an interface, so we will get we will define in the non-functional requirement gathering, we will define which is the high prioritized functionalities use cases, and we'll define the complexity and priority of all the scenarios that we are testing, which falls under performance testing scope. So based on that, we will talk to the engineering teams and architects, subject matter experts, and application design teams to understand how much time it is taking for each individual component or from tier to tier. So from them, we will get all this information. Okay.
Okay.
Okay. So the tier to tier response times and the processes, the resource usage, the basic minimum utilizations. Okay, and the most important part is this one, systems. If you take any of the machine from your infrastructures of the application that is being tested, people always tend to say that when they are asked about what they monitored, they say that resource utilization metrics is CPU, memory, disk and disk and network. So you need to have the complete understanding on what CPUs that are used, how many cores it has. Okay, you should understand the speed of the memory, and there are some basics of memory like static RAM and dynamic RAM. You need to get some understanding on that. So you need to check all the metrics that are part of CPU, memory, disk, and network, and most importantly, how the traffic is distributed across your architecture. So how the load is distributed. So whether all the servers, if you are using an entire architecture, whether all the servers are being configured properly, the load distribution mechanism is configured properly or not, you have to check that. Because if you have 3 application servers, right, if the load balancing is not properly configured, that load balancer will redirect all the requests only to one single application server, even when the other 2 application servers are available. So if that is the case, in such scenarios, what will happen is that particular single server will get loaded and it will stop giving the response, and you'll start seeing the performance degradations. The reason is because if it is configured properly, it will distribute the load equally to all the available servers across the infrastructure, and you will get the performance numbers as expected. If you don't have this load balancing mechanism, efficient load balancing mechanism, it will give you so many other issues like performance degradation, service unavailable, server going down, connection prematurely shut down. You will see a lot of different errors with respect to HTTP 5xx errors. Okay, these are all server related. And if you see any of the 3xx errors, 300 errors, any status code from HTTP, that means that you are seeing all the errors from the client side. Okay. So 4xx are basically the access related issues, forbidden and other stuff. So you can go through, I can share you that information as well. So this is a typical performance engineering process diagram. So if you look at here, the first thing that you do is the requirement analysis, which is also called non-functional requirement gathering. Yesterday I have already explained that. So this is the place where you create some list of questions, you consolidate all of them together, and you share it to all the teams in the project to understand what is the exact requirement, what is your goal, and what is your objective of conducting various flavors of performance testing of your project, of your application or product. Okay. So the first phase is you get the requirements are same, but the terminologies might be different from company to company, and from customer to customer, and from organization to organization. Okay. So some people call it as SLAs, service level agreements, which is also called NFS, and some people call it SOW, statement of work, and some people call it BVM, which is called business volume metrics, and some people call it as KPIs, key performance indicators. So the concept is same, however there are different naming conventions for all of them. So in the requirement analysis, when you post non-functional requirement gathering, asking all the detailed information. Once you get all this information from all the teams, you again send the same document to the customer. You will have a call or a meeting to get a sign off from the customer. This is what the information we have. We just wanted to get cross checked. Once he says yes, once the non-functional requirements are finalized, it is you again who will take care of creating the non-functional test plan, and you add so many things in that. In the non-functional test plan, some people write only plan in that, and some people will have a strategy document. It is a different document. So some basically in a non-functional test plan includes both strategy and plan along with the estimation. Who plans the estimation? Now
Excuse
a
me.
simple question. Yes, please.
Yeah, so because I experienced this question on the non-functional requirement, are we going to discuss anything because different types of non-functional requirements, right? Like environmental, some security, regulatory or something. There are many things. So when I experienced that question, are we going to discuss anything on that? Or
Actually, we already discussed yesterday, right? I mean, yeah, I can give you some case studies. I told you, right? The first thing is you directly get a requirement from the customer. The second thing is the client has money, and the client wants you to he wants his application to be performance tested, and it is again the performance engineer has to do everything. Okay, I have 4 cases for that. If you remind me tomorrow, I'll explain you all the 4 cases. Okay.
sure.
Okay. Please don't forget. I'll do that. Okay. All right. So yeah, well, the non-functional requirement gathering document. There are again few cases. You will directly get a requirement from the customer. Okay. The application is already there in production, but it is not performance tested. The first case. The second case is the application. This is the first time you are doing you're doing performance testing for an application right from the scratch, which is not there in production. The third case is the client doesn't know anything about the baselining initial numbers or the SLAs or any information about the performance plan or strategy. So you have to baseline and benchmark. So the last thing is so the last case study is you will not have anything, not even a single point of line of information from the requirement side. So you have to baseline, you have to benchmark, you have to create your own environment. You have to baseline and benchmark individually from the component side, from every individual type, from the entire infrastructure. You need to come up with a plan, and you have to meet some SLA. So nowadays, if you take any of the product-based companies' requirements or service-based requirements, most of the customers doesn't know anything about something called performance testing or engineering. So it is again you who has to suggest the best approach, the right approach, selecting the best tool. Okay, which will checking the feasibility of the application. You have to select the tool, and once you select the tool after working for 5 or 6 months for JMeter, and you cannot go back to the customer and say that this tool will not work for our application or for our technologies. Okay, if your application is a video streaming application like YouTube, you have to do a lot of R&D to suggest your customer about what is the best tool. Okay, what protocols you have to buy, what licenses you have to afford for which protocol, and why. Okay, if there is a mitigation as such in the near future, you also need to address all of them in the plan, strategy, and the approach that you have. Now, I have a basic question to all of you. What is the difference between the plan and strategy? It is a common thing for all the manual testing folks and also the automation and performance testing folks.
A plan is completely it's like a roadmap end to end, where you are going to define everything. So what your responsibility and what the team's responsibility end to end, including your architecture and types of tests, everything. When we say the strategy, it could be kind of a high level where how you approach. So what is your strategy with respect to the performance testing and engineering with respect to the application? So simply, yeah.
Okay, thank you. So I'll tell you the simple difference between the plan and strategy. Plan is all about what we are doing. Okay, what we are doing from the day 1 till the day 90. If your timeline is defined as such. Strategy is about highlighting about your approach, how we do it. Okay, how many rounds of testing you do, with how many number of users you do it. So, I mean, what are the different flavors of performance testings that you do? So these are all highlighted basically in a strategy document. But most of the companies or other people working in performance testing, they have one document called non-functional test plan, which includes both strategy, plan, and estimation part. Okay, so here we in the requirements phase we do something called system sizing in parallel with requirements analysis. In the architecture and design, I'll tell you what we'll do. I have an article for that. I'll show it to you. From the coding side, yesterday I told you, if you remember, from the coding side, most of the times code optimization techniques, okay, and best coding practices and code reviews should be a part of performance engineering in any performance testing project. So if any of the development teams are not following the coding best practices from COE teams, or if they don't have these coding reviews, or if they don't have this code optimization process in their project life cycles, it will definitely affect the performance and it will not improve the performance in any aspect. Okay, so from the testing point of view, this is the place where you do performance testing and tuning. And in the production, you continuously monitor the applications, the infrastructure to understand what is it, to understand what exactly is happening. Like from the APM side, when you continuously monitor something, you have a concept called you have three different things. Okay, one is hang on for a minute. One moment, please. Okay, I'm sorry. I got some call. Okay. Okay. So there is a concept in APM when you continuously monitor something, especially your infrastructure or any server or anything or any application side or the client side, server side, you'll have a big list of metrics. You have the first thing is called alert. Okay. If your CPU is exceeding more than 80%, you will get alert. Okay, you will get an alert saying that so and so metric on this instance on this server has been exceeded more than 80%. This is an alert. The second thing is called alarm. So alarm will be on top of alert. Okay. The third thing is anomaly. Anomaly, you will get it on the top of alarm. So you have alert, alarm, and anomaly. So if you get anomalies right, you will have hundreds of under anomaly, you will have hundreds of alerts and alarms. So there is a saying that there is a concept in APM called fixing the deepest node. So in anomaly, if you have some 99 alerts or alarms under one anomaly, so if you are fixing the deepest node, the first occurrence of that particular bottleneck, it will fix the remaining 98 issues. You understood the point? So there are many concepts in APM, but when you come to this production monitoring and capacity planning, They do capacity planning, or they jump to a conclusion whether to increase, whether to do scaling horizontally or vertically, or if they want to increase something, they come to a decision based on these alerts, anomalies, and alarms that you see from the infrastructure when you continuously monitor. So in the system sizing, so this is, you need to analyze all these business requirements for performance. Like you need to understand the end user response times, the number of concurrent users, the number of business transactions during peak times, and you also need to check for batch completion windows and growth rates. Okay, you might have a question that what is this, where can we get all this information? This information you will get from all the teams. Okay, when you sit with all the different teams, you decide the baseline numbers of all these areas, and accordingly you plan your test. Okay, and this sizing is typically with respect to a reference called TPMC. You can make a note of this one. How this there are some standards, TPMC A, TPMC B, and TPMC C, and you can check for this one in the internet. So in the architecture and design review, yeah, you will talk to the design teams and development teams mainly here. So to understand how they are taking a stand on designing the architecture to meet our performance requirements. Okay. So again, it is not the performance engineer's job to check whether the development team is using the right algorithms or data structures, but the development team has to take part of the development team has to take part of all this information. They have to check whether they have to keep a track of what algorithms that have been used and what data structures they are using. That is why the reason yesterday, if you remember, I also told you need to have some basic 30 to 40% hands-on on core Java, not complete advanced Java. If you have some 30 to 40% hands-on on core Java concepts, it will help you to boost your career from both performance testing and automation side, especially Selenium. And it will also help you to do the performance engineering tasks very easily, as majority of the applications now across the globe are Java-based applications. At least 65 to 70% of them are Java, or sits on Java. Okay, you have checklists for that. So after that, there is something called code optimization. Everything when it is prepared, when it is unit tested, so they have to check all the code from the basic level, from the high performance side, and they have to rewrite the parts. Okay. Anyone have an idea about what is redundancy and what is redundancy?
It's a reoccurrence. I mean,
Sorry.
it's a reoccurrence.
Right. Redundancy code is nothing but like it is a repeated instance. Okay. There is something, there is a repeated instance or a reoccurrence of a particular code snippet, which is not really necessary, which is unnecessary. Okay. So the programmers will identify all that redundancy, the repeating snippets of all the code in the program, and they will have a quality code which is performing as expected. And choice of algorithms and data structures, you don't decide that. There are few other teams from the development side, the architects and SMEs from the Java side or from the development side, the way they perform all these reviews, practices, and all. And once it is finalized, once it is once they take sign off for that particular thing, they will come back. They will have a initial build once that is completely integrated, then that is being sent to the functional testing. Okay, so there is another question, like once the application is once the development team involves in all the practices, once they come back with the completion of their code, right, there is something called build. So do we, now my question to all of you is, when do we do performance testing?
Well, so the application needs to functionally tested. That is the most important thing. And I mean, at least to some extent, high priority ones, high severity ones, that needs to fix. At least you start up with something. But a full-fledged means definitely the functional area that needs to be addressed completely. That is the your initial step, I would say.
Right. Everyone. I mean, from the before 2 years. Okay. From the last 2 years, I guess. Okay. Before 2 years, my answer is if someone asks me when you have to do performance testing, I say that soon after completion of my functional testing. Okay, when the application is functionally stable. So in the current performance testing trends that are being followed. Sorry, someone has some question?
No, I said agile module has been introduced. So in that case, it will change based upon like what we used to do earlier.
Right. If someone asks you when you have to do performance testing, you can do performance testing at any point of time in any phase. There is something called early performance testing. Okay, which will eliminate the bottlenecks at the very initial stage in the development phase. Okay, early performance testing starts in parallel with the development. Okay, which is not tested more than 25 to 50 users. So a simple API testing, web services testing they all come under something called early performance testing. But again, as someone explained me just now, if you want to do the end-to-end performance testing on a web application, the application has to be functionally stable. At least 70 to 75% of the functionalities should work as expected. Because if the application is not functionally stable, whatever the functional errors that you get, that will be a very big issue in performance testing. Because if some record is not being found or something is not working, so instead of calling it as a bottleneck, it will be a total infrastructure error or the server error, which will not allow any performance activities to move ahead. So that is why the reason the functionality of that application should be stable. And when you come to this performance testing and tuning part.
Okay, sir, I have one question here.
Yes, please.
It's regarding early performance testing. So like how do we conduct an early performance testing as the development activities will be in parallel, because some of the functionalities will not be completed. So in that case, we will not be able to like script those particular functionality and test those, right? So how do we manage early performance testing during that time?
So are you aware of microservices architecture?
No, not exactly.
So the advantage of microservices architecture is, so it will minimize everything. Let me give you one example here. In microservices architecture, if something is down, okay, if something is not, some area is not working, so you will have that microservice, that part of code snippet, which is managed by Red Hat OpenShift. There is some concept of called pods and nodes, okay, that is wrapped up and that is managed by something called pod. So if you bring that service down, it will not, if you have idea in OpenShift, you can just bring that service down and you can start doing your changes on that particular service. The remaining services will run as usual, will work as usual without any single effect because of that particular issue. So in early performance testing, right, whenever you get some snippet from the developer saying that this is working, only that part you can work. You cannot work all of them in one go. So when developer gives you one piece of code snippet in terms of a service or in terms of a API, in terms of web service, you have to go and test only that web service. So you cannot go ahead and test complete web application. Web application testing will not fall under early performance testing. Early performance testing areas are testing all the APIs, testing all the web services, testing all the different individual requests, or testing all the different services that we have from our applications with the number of users that the clients wants us to test. Again, the last point is the complete end-to-end performance testing of any web application will not fall under early performance testing. Okay.
Yeah, got it.
So as I told you yesterday, performance testing and tuning activities are not limited and they are not specific to any years of experienced associate. Doesn't matter if the associate is having 1 year or 15 years, even who is product-based companies or some clients, if it is an individual contributor role, even if he is 15 years or 16 years experienced, even if he is an architect, he has to come back and he has to do the parameterization and correlation as well. If he's working as a one man, he has to be a part of benchmarking, baselining, capacity planning, efficient scaling, system configurations, tuning all the servers, ensuring changes that has been made as part of the release, hotfix, or different sprints. So he need to understand the SLAs, and its ultimate target would be only he will be doing the continuous performance testing until and unless he meets something called client requirements, again, which is called SLAs. Okay, you can go through all of them here. And monitoring and capacity planning, as I told you, it is you continuously monitor, you see which resources are consuming high amount of resources. Okay. Mahesh, you there in the call?
Yeah.
Okay, I'll share all the docs after the class. Okay,
Okay, thanks.
okay, these are few definitions that I have written here: resources, entities, response teams. So you can go through this article, but I don't know whether I can share this article or I cannot share. But I'll explain you this one. This is a TCS confidential article. It is something that they worked at TCS. So in the process side, this is a performance engineering process handbook. I can share it to you. I'll try to delete this logo. Able to see it, right?
Please make sure in the version history also in the for this document version history, if is there any naming or something, that is also good.
That's fine. That's fine.
You can remove the names as well, RK.
Yes, yes, I'll do that. I'll do that. So I'll take it and I'll forward it to you. Okay. So these are the most, if you look at the index, these are the important topics that are part of, these are the activities that are part of performance engineering process. Okay, you need to understand the need for performance engineering. And again, most of the clients and customers, right, the teams are limited. Like if the offshore team will do only performance testing, and the people who are sitting at on-site with the minimum of 10 years of experience will be having access to take part into the performance engineering activities. What I mean to say here is that's not easy to get access to all the web app DB servers, especially database servers if they're using Oracle, and mainly to the production databases. Okay. So these are a few areas. Not focus all of these things. So from here you have to check, okay, the requirements gathering, how you do workload analysis, and the sample report on requirements and workload analysis. So the transaction process analysis, and this is the most important part from here till here. Okay? The transaction process analysis not really that important. You need to understand how the architecture is designed for a specific application. Okay? What are the basic thumb rules to design an architecture? So how do we do this hardware sizing? And hardware sizing, right? This is a secret for every company, every vendor. These details will not be disclosed for any of the application. But you can understand the process of how you can do this hardware sizing. It's not that based on these footprints or based on these calculations, I go and select RAM and memory and network and disk capacity for database server. Okay, hardware sizing or architecture design, if there is an application, if I have some application, it's already there in live, but it is not performance tested. Users are reporting plenty of performance issues from different regions across the globe. So what you have to do is you have to understand the hardware requirements, the architecture wise, the design wise. The reason is because you will not you will not conduct all these performance tests on the same environment that you have in production. Now again, it is a performance engineer's job to create the mirror image of that particular instance, right? When you create that instance, even if you take some help from the tools team or the environment setup team, I would strongly recommend every performance engineer to request them and take part in creating that setup. How do you decide? How do you decide if the customer is saying that this is all my on-premise setup, I am planning to migrate everything to cloud now, you can start testing it on cloud instance. You have to tell that which cloud can help you, like which cloud you have to use. Is it a Microsoft Azure or AWS or GCP, Google Cloud Platform, and why? So the hardware sizing and design and architecture, techniques are always they are a very big asset to any teams, and they will not disclose any of this information to any team member in the project. These are hidden secrets only for the design teams and the architecture teams. They will not disclose all this information. But when you want to work extensively on performance engineering, you have to know how the architecture is designed, how the infrastructure is designed, or how the hardware and software configurations are decided on each and every individual server that we have in our architecture. Okay, what are all the individual components that we have? There are something like file servers and email servers and FTP servers. There are different components. You need to get understanding of the entire architecture of all the components, and accordingly you have to give the report. This is what has happened when it tested. Only when you understand all this information, whatever the conclusion that you give in the last phase when you publish the report, that will be more accurate. Okay, so I'll share you this document. There are it is clearly explained of every individual phase. I have already explained you this task. The first thing is analyzing you have to analyze the workload. You need to understand the impact. You need to get a detailed understanding. You need to have the feasibility study on the application. You need to understand the traffic, number of requests, number of hits by using some production traffic tools. After getting all those information, you will create a workload model, right? That is how you define a workload model. You create a workload model. After that, as I explained you yesterday, NFR, non-functional requirement gathering, is a part of client questionnaire document. You will get all the details there. and you prepare a non-functional test plan, which includes plan, strategy, and estimation. And this is what is explained in detail about requirement gathering here. Okay, these are use cases. So he is talking about business interactions and use cases, how to get all those information. Okay, the examples are clearly mentioned here. If you look at the use case 1 and use case 2, right, this is how you identify use cases, and you take the list of priorities, and accordingly you set some priorities and complexities of the use cases and scripts that you want to record, and you distribute load accordingly, and you will go ahead with performance testing. Couple of performance tests. Okay, so if you look here on this one, transaction throughput, batch jobs. Okay, if you look at this particular image, what do you understand from this one?
To the architecture, I mean, end to end from the UI to the backend.
Okay.
And also the response time. So what you are targeting below 1 second between database to app server and the app server to web server, the 1 second. That's what you mentioned. So it's from client to how the flow is until the database.
Okay. So I told you about timing targets, right? So the industry standard of the response times of any transaction, irrespective of any load, doesn't matter you test with 2 lakh users or 5 lakh users or 200 users, the standard response time in the market of any transaction is not more than 3 to 5 seconds. If your customer is not giving you any of the information about response times, the standard response times of any complex to simple transaction is 3 to 5 seconds. 3 to 3.5 seconds is a very, very good performance response time. Okay. So before you give, when your customer asks you what is the response times you're targeting, when he says 2.2 seconds, you can directly tell him that that is not possible when I test with 20,000 users, because the timing targets are already defined by the architecture team, and the database team has they are very much specific about the time that it will take to get the query executed. They are saying that it will take a minimum of 1 second to get the query executed, to bring the response and to send back it to the client. So when they are giving the 1 second response time on the database activity, you cannot give 2.1 seconds, because if it is when he says 1 second on the database server, in some cases it can go up to 1.2 or 1.3. Okay, here you already have at the web server, you already have 1 second. 1 second plus at the database server 1.1 second or 1.3 seconds, it is giving 2.3 seconds, 2.2 seconds, right? Which again you are crossing the SLA. So that is why the reason it is very important to understand all these timing targets. From web server to app server, it should not take less than 1 second. And from app server to database server, it should not take less than 1 second. And the total response, the remaining 1 second will take from client to web server. Now you are getting this 3 seconds, right? So that is why you have to understand these target estimations and other information. Okay, anyway, I'll send you this. I'll send you this document, but make sure that you're not sharing this to anyone. Okay. Say yes, no, or something.
Yes, please remove that logo also. I think at the
That
end,
is
as
there, but
it's a
make sure
shaded.
that you're not. So
Sure.
don't share it.
Okay.
Yes, please.
Yeah, please remove that logo also. Just making
Yeah,
sure.
sure.
Yeah.
No. Even my name was there in the last, so I have to remove it.
Yes. I think you need to do the quality test first before sending to us.
So if you have any questions from workload analysis, right? I also have written one article in workload analysis and performance testing. You can simply go to my LinkedIn profile, and you can go back and see how we can how you can create this workload analysis and performance testing. Yeah, and this is the article that I'm talking about. Don't try to focus on all the areas. So I have given one fundamentals, right? Given fundamentals. This is one articles of fundamentals. This is code optimization. Okay, code optimization process. I have this is the same information that we have in this document, my own writings. So I'm not sure whether I'll share that document or not. Let me check, because if there is some client ID, that will be a problem. So if you go here, you can. I have shared. So we have 3 articles here. You can go back. So I have clearly written everything here. How to use the reference model for sizing the workload estimation. So most importantly, this is the main important task for every performance engineer: how you have to estimate the workload. Okay, how you have to create the workload model. So you have to understand all this information before you create. You need to understand the peak hours, off peak hours, number of transactions, number of hits, number of web interactions, number of pages accessed, communication with external systems, or growth rate of transactions, data volumes, and other data entities. Okay. So if you have all this information, you can create a workload model. But most of the times, right, most of the scenarios, you will not be a part of creating all these workload models. If your application is a BFSA application, or if it is an application where it has too many number of users, or the application which is having very high user base. So this will happen uh, from the SME side. So before that, how many of you are more than 8 years experienced?
Srinivas?
Srinivas,
Chelva.
Sridhar.
Srinivas and Sridhar.
Mahesh.
So have you ever
Chelva.
prepared a workload model?
RK, able to hear me?
So the question to the people who are 8+ years experienced: did you ever get a chance to create a workload model?
Yes, we did.
Yeah, we have done.
No, I have not done.
So workload model, I think Kumar has already covered in performance testing in load runner, right? So these are all the information that you need to take. I have clearly written in these articles.
Hello? Hello?
Hello.
Hello?
Yes.
Yeah. RK, how are you? This is a new guy that just came today.
Okay. All right. Yeah. Thanks for joining. So you joined just now?
No, I joined before the class started.
Okay.
But I have a lot of questions that I want to ask, but I don't know if I should wait till after the class.
Yeah, you can wait. You can wait once we complete the class. I can answer all of your questions.
Okay.
Thanks for waiting. Thank you.
Yep.
So even the code performance engineering, application code optimization and its process, right? No performance engineer will be a part of this activity. But the reason for putting this article here is you do a lot of performance tests. Okay, you do n number of testings, or you perform a wide variety of tests with different combinations. But you need to understand there are few bottlenecks that you cannot identify, which are called fake bottlenecks and hidden bottlenecks. Yesterday I told you, right, that can be because of inefficient code, some redundancy in code, the repeatancy of some code snippet. It will create a lot of problems. So it will create application deadlocks. It will create blocked threads. It will literally halt the application to wait for 2 seconds, and then it will resume, or it temporarily goes down. These things, all these issues happen just because of the coding problems. Okay. In code optimization, what they do is, I have just showed you all the assigning timing targets, right? The reason for asking for 8+ years associates in this code optimization process and techniques, most of the product, I'm not sure about the services-based companies, but in product-based companies, you should, if you are 8 years experience, you should have hands-on experience, and you should be able to you should be in a position to understand timing targets. And if you see some code snippet, you need to understand whether it is the right one or wrong one. Is that really efficient or not? Or at least you need to understand, did someone follow some practices in this coding or not? You should be able to review the code. You need to understand the code. Okay, at least to the moderate level, not to the advanced level. So you need to understand the timing targets from all the areas, from functions, methods, objects, and classes. For this, you need to understand the basic body of a program. Okay, and there will be few trainings that will happen in my company on the code optimization techniques. We need to, that those are mandatory sessions for performance engineers. And we have so many tools, JProfiler or JPro or JVisual VM or ANTS Profiler or CLR Profiler, or there are YourKit Java Profiler, YourKit .NET Profiler. These all tools will profile your code, and it can tell you how much each method or each class is taking. It will clearly show you from in the pie chart diagrammatic representation, each individual method, each individual class, or the strings or arrays. It will clearly list all the memory, the CPU, the time it has been taken for every individual task. It can be class, or it can be method, or it can be anything. Okay, so this is the phase where you will involve. Okay, setting up the test data based on the expected volumes and growth. If the data is unique, you need to talk to all the teams, and you need to get a plan on how you can set up the data. If you are testing with 20,000 users or 30,000 users, if every data is unique, you will you need to create a data of 5 lakh records or 6 lakh records. Okay, bottleneck removal, elimination of bottlenecks will happen from the code optimization and code reviews. When we use these profiling tools, okay, what is the use of taking thread dump here? You will be a part of code optimization. When you take a thread dump, you will look at the thread dump. You will take different snaps of Oracle. I don't know why this is not working. Okay, so if you take the JProfiler, there are some demo servers. Okay, so I have installed the cracked version on other laptop. Okay, anyhow, so I'll show it to you tomorrow. Please remind me. I'll show you the JProfiler. So the main, so in what way you will involve in code optimization is, you will work on a JProfiler or JPro or any profiling tool. When you profile a heap dump, right, It will give you the entire information of all the classes, methods, and other elements, objects in the Java program, and it will clearly give you a list how much time each one is taking. So you can take a snap of that and say that these are the top 13 classes or 17 methods that are eating 19% of the memory. You take a snap of it, and when you send it back to the developer, he will look into all of those methods and classes. He'll give a fix on that. Then you do a performance testing again on the same with the same settings, and you profile it. If you see the optimized value of CPU, which is 19% earlier, which is falling to 9% or 10%, it means that the CPU, it means that the code on that functions, classes, and methods has been optimized. This is called eliminating the bottlenecks at the very initial stage during the code optimization process by implementing COE coding practices and coding reviews. Okay, in code optimization, I clearly wrote what to verify. Okay, and entry criteria and exit criteria here. Code optimization process, if you look at this particular get order details, right, when we assign timing targets, the overall target for this transaction for this particular use case is 4 seconds. Get order front end is nothing but what you see on the laptop, which happens from the web server, is 1 second. Okay, this is a SQL and stored procedure target on the database server, which is defined here as 1 second, and buffer target for other overheads. Okay, from network and other parameters, it is 1 second. So the timing target he has defined is 4 seconds, and even this means that irrespective of any number of users you test, okay, you have to get 4 seconds of response time. All right. So the setting up of test data, most of them have missed that point, I guess. I'll repeat that for you. Setting up of test data, as I told you, if it is very unique, okay, if you need some 3 lakhs or 5 lakhs of test data, you need to identify the format of test data. You need to take a help of test data tool. You need to buy a commercial tool. You need to give the format. You need to define some regular expressions, the format. It will generate the data for you. Once you get the data, you need to ask your DBA to upload all the data, all this data, into the respective database, into the respective table where your application is accessing. Okay, once it is successfully uploaded, you will manually verify from the front end. You will take some 10 records randomly. You search it and you confirm that the data has been uploaded successfully. And that is how you do performance testing with huge volumes of data. Okay. So trainings, you will have it, and most of the performance engineers still they are not aware of how to use the profiling tools like JProfiler or JProbe. And if you go in depth, right, of any profiling tool, it will take a lot of time. It is another different niche area. Profiling tools expert, there is a job role for that. Profiling tools architect. So who will be working on all the end-to-end profiling tools? Okay. So every profiling tool is unique. Even if you want to learn the complete JProfiler or JProbe profiling tool, it will take minimum of 2 months. And for that, you need to know the Java as well. Okay, these are all various profilers that we have for Java, .NET, Oracle, network, and mainframes. So code reviews we already spoke about. Whatever the performance bottlenecks that we see in any phase of the performance testing lifecycle and engineering lifecycle, that should be logged. Okay. The reason why I'm saying to log it is because there will be some fake performance issues. There are some temporary performance bottlenecks. There are some performance bottlenecks which are not reproducible, which cannot be reproduced every time. So every time you see some bottleneck, you need to log it, you need to take a snaps of it, and you need to take a timestamp for that. Okay. So the last phase of the final agenda of code optimization is they will define the timing targets. and they will check all these areas, and they will check from the unit level. They will send us some code snippets for some pilot runs, which is a part of early performance testing. And finally, after all these coding practices, from lot many recommendations and suggestions from the SMEs and architects, they will rewrite the code if required, or they will redesign the total code snippet. They will write the code snippet in one or three different ways, and they will ask us to test which one is performing better. Got it? There are a concept of creating runtime objects. You can write the code, you can minimize the code. If I'm writing a code in 90 lines by using runtime objects or something, you can write the code in 40 lines. You can reuse the code, but however, a runtime object will create will take a lot of time to compile and to get executed. Even if it is the code that is written in 40 lines, or if it is the other code which is written in 90 lines, the other code which is written in 90 lines will perform better. So from the coding practices or coding optimizations, you will understand all these things and you will come to a conclusion on how to define the SLAs, what should be your timing targets. Okay, we'll talk about hardware sizing tomorrow. Only thing that is left is hardware sizing, and architecture design also I'll explain you tomorrow. So from that we'll complete the section 1. Okay, if you have any questions, you can call me after 8. I shared my number yesterday, right? You can call me at after 8 on the number. You can call. I mean, you can call me anytime after 8. I can clarify your questions, and you can also text me all your questions on my WhatsApp as well. Okay. Any other questions you guys have?
Hello?
Yes, please.
Hello? Yeah, so Auntie, I was gonna ask a question on the tier-to-tier response time you were talking about. Do we have any function on the APM tool that will be able to give us that particular monitoring metric?
I think I think there is a transaction breakdown graph, and there is one metric in CA APM. I can give you that metric name by today evening. I'm not sure about the exact metric name, but I don't think so. All the APM tools has that particular functionality or that particular metric which can monitor the tire-to-tire response time. Yeah, but I can give you the metric name and metric description by today evening. There are 2 or 3 metrics which those are specific to web app and DB servers, which will calculate the time that has been taken on that particular server instance. So I can help you with that.
So you also talked about the workload module. On the workload module, I also sometimes hear people talk about the demand module. What is the difference between the demand module and the workload module? And how do we use this demand module and the workload module? Where and how we use them?
I mean, what exactly do you mean by demand model?
So sometimes when you test with performance engineers, I normally hear them say, this particular data, the size of this particular data is taken from the demand module. But I don't even know what they meant by demand module. They say normally we already size the application according to the demand module of the data that goes into that particular system. So I don't know what they meant by demand module.
Okay,
And sometimes I hear
uh,
again about workload module. What is the difference between demand module and workload module?
okay, demand. I mean, just ask you this question to understand your context in what way you're asking this question. Demand model, right? It used some statistical methods, and there is something called some kind of analytics that will happen on the production environment.
Okay.
They also, which includes some business intelligence inputs as well. So there will be a lot of from the demand model, right? This mainly focuses on the data model, which will completely focus, instead of response times, it will completely focuses on the throughput. Okay, so how much data that is being retrieved with the highest user base, that is nothing but demanding model. And this
Okay.
demanding model will even if you get some demand model, or if you get any requirement from the customer saying that you need to run a demand model testing, okay, using this analytics model or this statistical inputs that we have from the production traffic analysis, he can ask us to do that. But even if you perform in that, there is no guarantee that the performance numbers or the infrastructure that you have for testing can sustain with the demand model testing that you're performing on that environment. There is no guarantee at all. But when you do workload modeling, right, workload modeling, you take all the required inputs from all the stakeholders, and you already know how the load is being distributed, how many typical users will access or typically click on each and every individual functionality. So when you do this workload modeling testing, right, when you create this workload model, every test that you do will be under SLAs, or it will be inside or outside the SLAs that we have. But whereas the demand model, right, there is no guarantee. Even if you have 2 hours of duration of test, there is no guarantee the test will pass, or it will go as expected in the initial 30 minutes.
Great. So yesterday, I am so sorry I couldn't join yesterday because I thought the class was going to start today.
Okay.
So, but
Sorry.
I went through the video you sent yesterday. Then I realized you talked about the test environment and the staging environment, of course, production environment. I'm not talking of production environment. Now I'm talking of the staging environment and the test environment.
One moment. So the remaining people, if you can leave this meeting if you have some work. If you want, you can stay back. Okay. Thanks all of you for joining. We will connect tomorrow again. Oh, I don't.
Okay.
Tomorrow is Saturday, right?
For us, it is Friday night. So
for your students. So we will take the class on Monday. Okay.
Monday. Okay. Monday. Thank you.
All right. Yeah. Thanks for joining. Yeah.
Guys, Monday will be night for US folks. Just
Sunday night.
Yeah, it will be Sunday night for somebody who is living in US, and Monday morning for people in India. Just want to reiterate what sir has mentioned.
Okay.
Thank you.
Yeah. So Sunday night. Okay. Thank you. Thanks.
So like I said, you talked about test environment and staging environment. What is the difference between test environment and staging environment?
Staging, the difference is when we talk from the performance standpoint of view, right? We always prefer to have our own dedicated environment, which is a mirror image of prod-like environment. Okay. Whenever you do performance testing on a shared environments, that will definitely show some bad impact on the response times and other resource utilization metrics and other metrics that you are trying to monitor. So when we say a test environment, right, there are few test environments which are shared environments for manual testing folks and automation testing folks. But for performance testing, guys, it is really important to have a dedicated environment where only performance testing will be performed. Staging environment, it depends actually. staging environment or any other environment, production environment, it depends on your customer on which environment he wants you to test. For example, if you take my assignment, I test on staging environment, I test on QA environment, and I also test on prod environment. That is my requirement. And if you take majority of the cases, no performance engineer is allowed to test or run any kind of testing on production environments.
Okay. Okay.
Yeah.
Besides, there is a the capacity also, right, compared to testing and the staging. Obviously, the testing means the people who uses the QA team or something. Definitely, its size is almost limited compared to our staging, which is almost
No.
similar to production.
Staging environment is nearly exact replica of production environment. That is why it is called staging.
Right.
But staging
So,
environments are used for most of it. It will be used for all the activities like testing the codes, builds, updates, patch testing. Everyone will be using staging environment. But when I say performance testing environment, I'm talking only about the dedicated environment for doing all our tests.
okay. Sorry, I am a new guy to the performance system, so I just want to get it correctly. That's why I'm asking these questions.
No problem.
Again,
You can ask me questions anytime.
Yeah. Again, when you are preparing your test plan, now you get the non-functional requirements from any document they give you, whether it's a BRD or any CR change request that they sent you. Normally, I see it's very hard for me to actually get the test cases from this non-functional requirement. When I came to the testing field, I thought the functionalities in the application are actually the test cases for the test. But when I started doing performance tests, I realized that these functionalities for the application are only used for you to get a script that you will be able to send to the controller to test. For example, you have an application that says login, add something in the cart, then log out. Those are functionalities. Those are modules, as we call them. So when you have them, you use them in order for you to actually build a script that you send to the application, to the controller to do your test. But now, here comes my question. How would I know that this is the test case I have to actually use in order for me to do my test? Where do I get those test cases? How do I determine those test cases?
So yesterday, you have not joined the class. So if you are asking, so which use cases or which test cases has to be considered for your performance testing assignment? So
Yes.
you mean to ask like, how do you know which scenarios that you need to consider, right? If I understand you correctly.
Yes.
Okay.
Like you have stress test, you have load test. So now I want to go do my test. Now I know I have already got my script from, if I'm doing a performance test through Load Runner, I've already got my test from the ViewGen. Then all the functionalities, I click log in, log out, everything is there. I enhance my script. Now I'm ready to go test. What are these test cases? Where do I actually get these test cases? That is my problem that I'm always facing. Where do I normally get these test cases? Are these test cases coming with the BRD document, or I am gonna sit down and determine these test cases that I'm gonna continue doing my tests?
Okay. So let me answer your question. Okay. So when you have an application, right, most of the times when you do performance testing, right, it is 80 to 80% of the times you do something called load testing. That means that you will have number of users and you will have the duration that you have to test. For example, you know that your application can handle 100 users. Okay, you know load testing, right? Load testing, I'll not explain you the textbook definition. I'll explain in my style. So load testing is the maximum number of users the application can support. That is load testing. Okay.
Yep. Yep.
So you know that your application will support 100 users. The maximum handling capacity of an application is 100 users. You test with 100 users and you publish the result. That is load testing. So you can, from 1 to 100 users, you can test with any number of users for any number of hours duration if you have some good infrastructure in terms of hardware and software capacities. So when you say stress testing is nothing but this is usually done to identify the break-even point, to know the crashing point of the server. Stress testing is basically more than the number of users the application can support. Like, you know that your application will support 100 users. Now you stress your application. You'll test with 105 users, it is passed. You test with 110 users, it is still passed. You test with 115 users, it is passed. And with 120 users, it is failing. It means that the load between 115 and 120, somewhere it is failing. It can be 116 or 117. Okay, this says that the application is failing at this point. It's nothing but more than the maximum number of users it can support. And again, when you do this stress testing, right, you can stress the application in n number of ways. You can, if you can downsize your hardware of the application server, or you can decrease the network bandwidth, or you can wantedly stress your application in multiple ways. There are multiple ways for that. You sometimes you test with Chrome browser, sometimes you will test with IE6 or 7 version, which got very low performance comparatively with 11 or 10 or 9 or something. So when you talk about endurance testing, basically this is a long time run where you will focus on all the memory leaks, which will run for a minimum of 4 hours, typically to 5 hours or 10 days, or it depends. Minimum run is 4 hours. So spike is again if you want to suddenly increase the load, you know that your application will work with 100 users. It is running for 2 hours, and after 1 hour you are increasing another 50 to that to see what is happening to the application. This is nothing but spike testing. Okay, reliability testing, again, reliability testing, if you have some minor change, some hotfix or upgrade, right? If you want to test that particular thing, something which we can trust on, you will go for reliability testing. So when you asked what are the scenarios that you have to test, how do you understand what scenarios that I have to consider for my performance testing? For that, you need to get the production logs data to see the hits, to see what happened in the production application. That is one point. Second point is you need to prioritize the use cases. Example, if you remember, I explained, right? Let's say that let me log in here. So log out. Okay, if you have many functionalities here, there is something like continue or something like selecting a country here. or some
Yeah.
people will be clicking on help privacy. You need to understand when you see your application, you need to understand how many users typically, how many number of users in an applications are clicking on help button in a day. This is a very low prioritized test case, right? Some people,
Yeah.
some 10 to 15% may click on privacy, and 1 to 2% will click on terms, and only 2.5% will be selecting this location on daily basis. So accordingly, you need to understand the priority of that application. And once you get this production logs data, this is where you create the workload model. In this workload model, you create, you consider all the priority use cases which you need to consider for your performance testing. And if you need more information, you need to talk to all the teams, especially with the business teams, and also to your customer, which business cases or use cases that you need to consider as high priority. Got it? So
Yeah.
if all the answers for your questions are not answered, you can go through this article, workload analysis in performance testing. This will give you more insight. All right.
Yeah. Okay.
Yeah, okay. Sorry, Vinod here.
Vinod.
Yeah, hello.
Yes, Vinod, please tell me.
Yeah, I have a quick question. Okay, so you are telling about now also you told something about the workload modeling. Okay, as a performance tester, as an engineer. Okay, if there is a brand new application, there is a production volume. Okay, so how we can handle this situation, or how I think you explained about some basic things, general things you need to follow about the response times and other things from the breakdown of response time. Okay, when it comes to workload criticality, okay, about this business flows, okay, how much volume or how much things to be included, whether the performance engineer will be responsible to take that call,
Yes.
apart from response and other things.
So yeah, if I understand you correctly, you are asking me if there is no single input and it is a brand new application, how do we take part in workload modeling, right? How do we create it? So what is the role of a performance engineer there, right? Right. So there is a lot of concept for that. I have to explain you all the business.
One question:
role.
whether the performance engineers, yeah, correct. Whether the performance engineer will be able to.
Yeah, he'll be able to do that. He should do that actually. This question is asked in every interview actually. So there is a very big role for performance engineer in this scenario. He has to understand all these things, and he has to give a conclusion on. He has to suggest to all the teams which scenarios has to be considered for performance testing. So and how accurately the workload model has to be created. There are the performance engineer will take part in identifying the scenarios, and he will ask the SLAs for that, and we have to understand how much of data and what format of data that we have to create, and how many load generators that will be required for creating this workload model for all the for all the use cases that we identify. And there are many more things like identifying the objectives in terms of response times, throughputs, and most importantly, the application understanding. Until and unless the application team comes back to us and says that these are all the areas that we have to mainly focus, you cannot directly go and create a workload model. So the application understanding, after getting the detailed application understanding, so how many types of users are using the application, or what business scenarios, or what is the expected growth, how long the peak activity will continue. These all things has to be discussed, and you need to identify the key scenarios. You need to identify the key scenarios. By simply, it can be. I will not say that it is a simple task, but you have, as you don't have anything in hand, so you have to check for the most critical business scenarios, or most resource intensive scenarios, and most frequently accessed some kind of measurable scenarios, And the last point is this is called stakeholders customers concern scenarios. Customer is really concerned about the feedback that we get, or if you want to focus anything in specific on that particular area, so you will focus mainly that. This will happen only for the very first time when you create a workload model on a brand new application. Okay.
Yeah,
However, I have a
Okay.
document for that, Vinod. So how to create a workload model when you don't have anything in place? I have a document for that. If you ping me on WhatsApp, I can share it with you.
Sir,
Okay. Thanks.
Can you please share with us also, RK, please, that workload model, if you don't have any requirement or something.
Yeah, sure.
I have one question I was waiting for. So, RK, I feel maybe I'm missing something. So, when we talk about the environments, right? So we have the development, you have the QA, and as you mentioned, you have the performance, then the staging, then the production, right? I rarely see the staging, to be honest. The companies I did work, even when I work at the large clients also, I haven't seen the environments which exactly matches to the production. We always see, maybe I'm missing, maybe other clients where I didn't work, of course, but I haven't seen the environments which exactly matching the production when you did the performance testing. Always it is 60, 70% most of the time I did. Is it
Yeah.
that is what something or no, because we tried that. Then they said, okay, well, so UAT is the best for you. We cannot build for you the performance environment all the time. So it's going to be cost, right? So just go for the UAT where it is 60, 70%. That's what I got the answers so far.
Even if you take any client, right? Even if you take a very big chain, no company will give you the exact mirror image of prod-like environment.
Correct.
No chance at all. The reason is because performance is very, very expensive. Point number one. Point number two is, even if you buy StormRunner cloud license for 3,000 virtual user days, there is a VUD concept which calculates the duration of the run and the number of users. It runs on that principle. If you buy 3,000 to 4,000 users, they'll charge you 4 lakhs. And you cannot run, if you run a test for 8 hours with 1,000 users, 3/4 of the license will go will be used. So when you run with when you really want to run a test with 80,000 users or 1 lakh users, right? You need a very, very big infrastructure. You need a very big team with lot of experts. If something goes down, they need to bring that up. If, for example, my product is organized by my product company sits on artificial intelligence and machine learning algorithms, which is completely managed by OpenShift, Red Hat Kubernetes, Red Hat OpenShift Kubernetes Dockerized, containerized environment. If you want to create the exact environment, you need to invest crores and crores of rupees. So we have 1/3 of the environment, 1/4 of the environment, where we can publish the result only to 1/4. Yesterday, as I told you, I am not multiplying it by 4 and I am not publishing the result. If the customer is having that money, we can depending upon his money, we can cook that bread for him and we can apply the quality of sauce that comes in his budget. That's all. There is no specific, there is no provisioning of the exact mirror image of the environment. Most of the projects.
So just a follow-up question to what Sri has asked, sir. So let's say we are going with 1/4 of the environment, and as per the workload modeling, let's say we are supposed to test with 1,000 users for the full environment. So for this 1/4 environment, are we supposed to test with 1,000 or 250? Just out of curiosity, I'm asking.
You're asking me, sir?
Yep.
Yes, sir. Because I faced this mystery many times. So I had my own calculations, but I wanted to understand the industry
nominally
standards.
we will run with 300 to 350 users, sir. So if it is working fine, the maximum number of users as per industry standard will add 5% to the existing capacity, and we will run with 350 users to see whether it is going as expected or not.
So we will not
Because
test with the whole 1,000 because we have the environment only
no,
1/4.
because the memory footprints for 1V user, how much memory does it take? The CPU and disk, how much does it take? Accordingly, we'll calculate and we'll set up the environment with respect to hardware and software, especially with infrastructure side.
Okay.
So when you have that numbers in our mind, we create that environment and we create we run the users only with 1/4 of the size.
1/4 only. And one more thing, sir, just a discussion. So I was involved in one of the project where it's a starting one. It's the first time it was going into production, and we didn't add any statistics or any user load or transactions per hour. We didn't have any of it. So what we as a team decided is we will go with a single user baseline test and a stress test. That's about it. So is this a common practice in the regular thing? I mean, with your experience, is this something that you consider, or you speculate the numbers and then you do your workload modeling based on the speculation for a completely brand new applications?
For a completely brand new application, always my first preference is to ask the customer what are all the customer concerned scenarios. The first question is there are some stakeholders concerned scenarios. So that is the first thing that I would ask for. So what are all the areas that he wants us to focus? After that, we will identify the key scenarios, and as you said, we will baseline and benchmark with 1 user, 5 users, and 25 users to see what is happening with what. That is the first thing. We'll also identify the measurable scenarios. That is a basic criteria for selecting any scenario for performance testing. That should be fully measurable. Any scenario we take it, and we take the mostly frequently accessed scenarios, high prioritized, and business critical scenarios. That is how I do for the very first time.
Okay. So thank you, sir.
Let me come back.
Okay,
So-
so adding to Kumar's question again, because we have been facing this question again and again during the interviews, and it's always challenge for us. So you are saying 25%, you have the capacity in the UAT, okay, you are going for it and you are certifying 250. Then maybe you go for more, maybe 100 or 50 users, you are saying that, okay, this is good for, as per the per user and as per the 250 as per our capacity. So we are certifying that. But the question comes from the client or maybe from the interviewer. Then, so what is the point? So I have 1,000 users and you are certifying me for 350 users. Well, yes, I have the 1/4. But how I should be confident to go into the production or in the live with 1,000 users? That question comes. So my answer should be, well, if that is your question, okay, give me the capacity which I have the production equivalent, then I can prove it with 1,000 users, whether it is capable or not. I can answer that. But to make it convenient to the interviewer or the client, well, I don't have the budget. You tell me, because I go by your confidence, what is the, at least to some extent with the risks involved, what is the things you are going to give it to me? If that question comes, what is your answer? It always challenging us, It's clear, right, what I'm trying to ask, RK? Hello?
Okay. So see.
Sorry, we are over testing you. I know.
No problem. So the question, I mean, whatever the question that you have asked, this question is faced by everyone almost. So again, as you said, is absolutely right. Like you cannot go based on assumptions, right? So for point number 1. Point number 2 is you never know when the users are continuously accessing the system. with the limited capacity that you have when you want to test, it is it is highly impossible to say that the response teams or the resource utilizations or other metrics that you're monitoring are under SLAs. So when you want to test with 1,000 users, you have to you need to get the sufficient capacity of the environment to test the client requirement that has been asked for. But again, when you are testing everything on one fourth of the environment with 250 or 300 users, you cannot give a conclusion or you cannot say anything on that. You cannot comment anything on that. Even if the client is asking you or forcing you to give some kind of assumption on that, it will create a problem for you in the near future if he gets some other issues from the environment when he tests, right? And what you have to understand here is the production issues and the issues that you see on the test environment, even if you test with the same configurations, same simulations, same user base, the issues that you see are different.
Because it's a synthetic, right? Compared to
Synthetic, and you tend to work on the virtual environment which is not really existing, and that is completely a simulation kind of activity, right?
Yep.
So even with whatever the best tool in the market that you're using for your performance testing activities, it doesn't mean that whatever the results that you're publishing are very close to the real-time results. LoadRunner will give you the 85 to 89% of the realistic result. It will sit close to the real result. Even JMeter will not give you that. Neoload will not give you that. So the question for your the answer for your question is like we cannot give any conclusion on that. If he wants us to test for his requirement, he needs to give that environment, and we have to do that. And we have to publish the result as we will have some proofs from the APM side in terms of pie chart diagrammatic representation. We capture the graph, say the client this is what is happening, and this is what has been fixed, and this is what has been improved from last release to this release. That is the only answer.
Perfect.
All right. Any other questions? I have 5 minutes.
Yes,
I have to start my office.
I have. Let me just ask 1 or 2 more questions, then I'll leave the rest for tomorrow. So, whenever you have an application to test, let us say the application is using users as load. Now, normally I hear about concurrent users and normal users. Which users do we actually use to test the application?
Normal users.
The normal
concurrent users, there is a different testing for that, but concurrent users also you can create some kind of concurrency, like 50 users concurrency in 1,000 users test, but you cannot directly test with thousands concurrent testing. Okay. So what will happen if you do 1,000 users concurrent testing? If you are putting all the requests in one go onto the server, even if it is a fully automated server, it may not understand your all your requests, and it will fail to respond. So yeah, we will work on the normal users mostly.
Yeah. So there was one time they gave me this. I was working on one application with one of my co-worker, but actually he didn't give me the concurrent users. He just gave me the number. He calculated it and gave me the number from the main users they gave us. But he didn't even tell me how he did it. Do we have any like a formula or something that we use to actually calculate those concurrent users?
Formula for calculating the concurrent users we don't have, but for workload model only we have something called Little's law. So I would request you to go through this article first. Okay, you will
Okay.
understand what is the information and what are the different things. If you see here, I have listed
Oh, yeah.
everything: user pattern, types of users,
Okay.
number of registered users. Okay, online
Yes.
transaction pattern. I have
Okay.
clearly written everything. You
Okay.
can check
Sandeep
Yeah.
can
everything.
give the better answer for that, I guess, RK.
Sure. So
Right?
last question for me. We were working on an application, then I was doing the monitoring. I was monitoring the application through App Dynamics, but I was using the dashboard for the application. But during the test, there was no bottlenecks. I didn't see any bottlenecks. But the performance engineer that was testing with us actually came to our desk and say, hey, the application is throwing errors. But I didn't even see it on the dashboard. The dashboard was normal. How did he know that the application was throwing errors when I didn't even see it on the dashboard?
You might have not configured all the metrics of that particular servers onto the dashboard. Okay, because the performance engineer will have access to all the servers. He is the one who will download, configure all the respective agents to all the web app DB servers. And once he configures and once he establishes the connection between the application and the APM solution using agents during the load test, everything, every activity, every hit, every error will be captured, including with errors per second, errors per description, everything. And accordingly, he will get to know all this information. So for that, you need to have access to all these machines, and you need to configure all the agents up, correctly. You should have all the proper configurations to all your target servers.
He's gonna see the error on his own machine from the tool.
He can see that on the APM itself. APM, if you go to the server,
APM
he can
itself.
directly go and see all the metrics.
Okay.
All right. Okay, we'll
Yeah.
continue the remaining questions.
Okay. Thank you so much.
Thank
so
you.
do we have
Thanks a
a
lot.
class tomorrow? Do we have a class tomorrow?
No, we don't have a class on Saturdays and Sundays. We have a class on
Okay.
Monday. Monday, 7 a.m. IST. Okay, please make a note.
Okay.
Okay,
Okay,
thank
no
you.
problem.
Thanks all
Thank
of you
you
for
so much.
joining. Yeah.